Thank you, Mohit, for being part of XRO, which is India's first AR/VR MR podcast. So, for my audience who don't know about you, I'm just going to give them like a brief introduction. So, Mohit Deopujari has been part of companies such as Adobe, Nvidia, Qualcomm, and he's currently the Volumetric Pipeline Technical Director, Graphics Software Engineer at Intel Studios. Welcome to XRO podcast, Mohit.
Thank you.
Really happy to have you. And I'm really keen to understand the future of storytelling because I think Volumetric is going to play a huge role. I mean, people are just grasping at the possibilities of what's gonna happen with the future of narrative because it's taken 100 years with the 2D platform, and that is dying out. And what's coming is the spatial computing, and what's coming is the virtual reality, augmented reality, and what's gonna drive possibly the storytelling is going to be volumetric. So to my audience who don't know what volumetric is, let's just start from there. Let's explain to my audience what is volumetric capture and how was it originated.
Sure. So I'd say volumetric capture is like the capturing of a 3D environment or a 3D scene and being able to view that content in an immersive fashion. And when I say immersive, you'll hear this word thrown around a lot. So when I say immersive, it means you can actually interact with it like a real 3D scene. Like you can walk into it, you can walk out of it, you can look around and see the things, like you'll feel like you're already there. So that's something that's really special here in volumetric video capture. And it's been around. So this whole technology came out from photogrammetry techniques, like old techniques of stitching different camera photos together and being able to make a bigger scene out of the multiple photographs. So that's where it started, and it's evolved into becoming like into 3D video where you can view the scene and you can walk in it and you can even play it back. Like you can see the things change and you can interact with it, and it's pretty crazy.
Yeah. So I think we're living in exciting times. I guess no matter how much we tell or explain the audience, I don't think they will understand until they actually experience it.
Because that's something you have to see for yourself.
Yeah. So I have at conferences, I go talk to people, and I keep on telling them the future is virtual reality, the future is volumetric, but they fail to grasp what the possibilities is. Where the entire scene of maybe a movie or whatever could be simulated exactly like how a real world plays out. Where
you could view a scene. Yeah, you could view a scene in your room, like you're sitting in your room and you have this VR headset and you look around and you find yourself, you're in the middle of the movie and you see your actor in one corner and there's a villain in the other corner and you're in the middle of the shootout and you're trying to get out of it. So that's the kind of experience that you can achieve here.
Lovely. So yes, I think it's so very exciting, and the possibilities of this can get completely endless, right? And when it goes mainstream, at this point in time, I'm sure there's a lot of challenges with it. So let's get on to that later. So tell me, so Intel Studios happens to be one of the first volumetric capture studio in the world. Am I correct on that? If not, please tell me about. And it's one of the biggest volumetric studio, right?
For sure. Yeah, Intel is definitely the world's biggest volumetric studio facility. And we're not the first, but definitely the biggest. And we're based in Los Angeles right now.
Right. So can you start with telling the audience how does a volumetric capture work? The workflow behind it. What is used? How do you capture? What's the size of the studio? How do you capture content?
Sure. So for starters, our stage area is like 10,000 square feet.
Wow.
And we have a huge dome kind of structure. And we have 100 cameras placed on all locations. So we are capturing anything that is happening on the stage from all possible camera angles. And then you have all this data. You have captured this footage from all these camera angles. Now you can apply photogrammetry techniques, computer vision techniques, to do 3D reconstruction of whatever you have captured. And what 3D reconstruction means is you will be able to get the information of any object in the scene, not only the X and Y positions, but also the Z dimension, like X, Y, and Z, all the 3 dimensions. So you can figure out how deep is that object in the scene. You can actually go there. Like if you take 10 steps, you'll find this object. If you take 20 steps, you'll find another object. So it has this depth connotation to it, and that's what's volumetric are all about. And that totally differentiates it from 2D video. So in 2D video, you have, let's say, every data point is a pixel on your screen. It has an X and Y value associated with it. But in 3D video, you have X, Y, and Z, like I said, and it's what we call a voxel of information. So volumetric pixel, you can say. And so, yeah, to do that, we, like I said, we need a whole lot of cameras. You need some really strong computer capabilities, and you need some good software. So you apply all these techniques, you get this 3D model out of that, and then you do it frame by frame, all these cameras which are time synced. And then you get this video, and then you can play back that video, and then you can do fancy things with it. So that's what it is.
Wow, lovely. So back in 2016, when Google was building their VR camera, Odyssey was, I think it was a 12 camera rig or something like that. We built our own 16 camera rig over here.
Oh, nice.
Yeah, and I directed, produced India's first telescopic VR horror short film. And I remember that because there was so much back and forth. First of all, acquiring hardware. We went and purchased some a 20 plus Yi cams from China. Google at that point of time had just an array. We added top bottom, so we wanted a complete telescopic. Now to take the 16 cameras onto editing software, stitching it seamlessly, avoiding the parallax as much as possible. That was so painful. We had so many problems with a 16 camera.
Yeah.
So can you walk us through the challenges of 100 cameras, capturing them? How does it work?
Oh yeah, sure. So let's say you have one camera, right? Then you need to add another camera to this setup. So you need to have them time synced first of all. We are capturing at a very high frame rate, let's say 60 FPS. So we have all these cameras. We keep on adding in the array. We have them in multiple locations. These are being controlled centrally, and they have a global timestamp associated with each frame. And each of these frames is being captured at the exact same moment. So the shutter is also a global shutter, and the shutter is closing and opening at the exact same time in all 100 cameras. So that's how you are getting nice, timely synced information from all these cameras. So that's the first part. Now, what do you do with this footage, right? So the first thing is you need to have storage. So each of these cameras need to have enough storage to hold the whatever footage you have captured. Then you need to be able to process all this footage from all these 100 cameras. So for that, you need some really nice heavy duty storage. You need to keep it in one place to be able to process it later, like you mentioned, using all your editing softwares, and you have all these 3D softwares out there, the photogrammetry softwares. So that's the first part of the capture. And then the next step would be calibrating all these cameras. So you need to know in 3D space where each of those cameras are actually located. So that's a crucial thing, and everything else is based on that. So once you know in 3D space, that is where all your cameras are, that is also calculated using fancy computer vision techniques. You have some calibration patterns that you can use. And once you have that information about each camera, then you go on to do your regular footage capture. And a lot of it after that is pretty much similar to 2D video footage capture, where you start a scene, the director calls action, a performer does their performance, and then you cut. And right after that, you have all this footage coming in. You can store it on your hard drive. You go in, you start doing all your 3D reconstruction algorithms. But again, all of this is you're working together on 100 camera footage. So it needs a lot more computer power, a lot more high duty, even optical fiber that relays the data. That needs to be heavy duty as well. And all those technological advancements that have been happening over recent times, those are in use here today.
So I've seen a couple of footages, the Grease footage, then there was this Western cowboy sequence which was out I think a couple of years back, and I think 2016 I think there was this first clip of this ox or a bull. I mean, it started from
Yeah, that was like a demo.
right from there. Right? So can you just run us through some of those challenging jobs that you have done? What was the most exciting experience or demo which you have been part of and built at the Intel Capture Studios?
Uh-huh. So recently, well, first of all, that demo video which you're talking about, that was a huge feat in itself. Like you have to bring in
Exactly.
horses, huge stand on all these animals, and so everything is very different here when you're doing 3D capture. All the way from the pre-visualization stage to the post-production stage of filmmaking. The director who's making this video, he needs to think in terms of a virtual camera. You don't have a single camera, you have all these different cameras. Even the set design, it needs to take care of all the cameras. You don't need too many cameras being obstructed by all these objects on the set. So you need to be really cognizant of the fact that there's 100 cameras looking down at the stage. You don't need to block most of them. So that's the initial part. Then the actors need to be trained on how to work in a 3D setup, because they're used to a single or maybe a 2 or 3 camera setup. They're used to looking at a camera or looking at one point, but here they're being captured just as is. So they don't sometimes know where to look at or how to act. So the director has to guide them and train them on that. And after that, your traditional techniques of image segmentation on a single camera or background removal, those things have to be scaled up, because you have to do this again for 100 cameras. So that's one of the biggest challenges that comes here. And recently we did a shoot where there was a pogo stick sports person. Like he jumps on a pogo stick,
Right.
and he was trying to attempt to break the world record of the highest pogo stick jump on our stage, and he almost missed it. He almost got it, but at the end he couldn't break it. But watching him go 15-20 feet in the air and landing nicely on a pad, that was really interesting. Like all the stage setup that went to it, and when it was happening live in front of our eyes, that was really crazy.
Lovely. And I'm sure when you actually transfer it into an augmented reality experience, when somebody can view that there's this person jumping right in front of you, I think it's going to be a crazy experience.
It's pretty
right?
crazy.
Yeah. It's going to be crazy.
When you see that on your tabletop and you share it with your friends, and your friends are seeing that with you, it's a totally new way of interacting with video. Yeah.
So tell me, I mean, what's the challenges of transferring this onto an augmented reality experience at this point in time? Is 5G, do you think that 5G could be a technology which could drive this conversation forward?
For sure, totally.
Yeah.
So yeah, well, today we have this video. Like I said, it has 3 aspects to it. It has the X, Y, Z dimension on each data point. So naturally, the video is very big in size. Even a 60 seconds video will be like 17 terabytes of raw footage in our facility. So we have to first bring it down into a 3D playable format, which is like a polygon format. And then you have to be able to compress it so that your devices that you have today, like your VR headsets, your cell phones, or your tablets, they should be able to play it back, all this huge data. So every single frame is so many megabytes of data, and when you play it back, your device needs to have the compute capability to play it back smoothly without any frame drops or anything. So again, the second challenge there is, how do we get that data to the consumer? Because all these data distribution channels that we have today, they were designed and with a regular video format that we have, 2D video format. They were designed with keeping that in mind. But we have multiple gigs of data for even a minute or 2 of video footage, of 3D video footage. How do you get that to the consumer? So I think 5G is going to be definitely useful there. And once you have all that data, you need to be able to play it back on a very fast device.
Right. Yeah. So I think we're living in an exciting space, and somehow I think this natural disaster of COVID-19 is going to accelerate all of these these technologies, which has been on a creeping mechanism. People normally are a little averse to change. So the adoption has been a little slow with all of these technologies which I believe can be extremely transformational. Maybe COVID-19 just could accelerate
Oh
these
yeah, it's
technologies, and
definitely gonna
possibly,
precipitate a lot of.
maybe bring these kind of really futuristic technology into the present time. So can you talk more about some of the use cases? And I was just going through your LinkedIn page and I read about
Mhm.
this sports person, John Brenkis, and
Mhm.
his Soul and Science app that he's bringing in
Mhm.
partnership with you. So
Oh
maybe
yeah,
like, you could just talk about some of your partnerships
sure.
that's happening, and which you're really looking forward to.
Mhm. So Soul and Science is an app which is going to be coming out on your Play Store, on the Google Play Store and the Apple iStore, I think very soon. And here we have sports-related content. We have all these athletes come into our stage, and they're doing what they're best at. They're doing their athletic stuff. And what this app is going to tell you is the science behind that, uh, behind the athletes, how they are performing. So let's say you have a volleyball player or you have a pogo stick guy who's jumping up and down. What is the science behind it? How high is he able to jump? What is the physical limitations that he is encountering? And all that you will be able to see in a 3D environment. Like when you can view this content on your tabletop using your cell phone through this app, but you can, when the person is jumping, let's say, you can change the point of view. You want to see him jump from another point of view. You want to see how it looks like from another camera angle. You can do that because you have the app in your hand, you have the phone in your hand, you have this 3D world in your hand, which you can move into, and it's totally immersive. And it's a very different kind of experience. It's educational at the same time as entertaining, and it's something that people have not seen too much, and I'm pretty sure people will love it.
So, what do you see as the drawback of this technology, volumetric?
Mhm.
Is the price point a problem? Is the interface a problem? A device which can
Mhm.
take this to the general people? Is the computational power a problem? Is the technology like 5G is a problem? Where exactly you see the problem? And
Mhm.
who do you think is going to adopt it first? The sport industry, the Hollywood industry.
Yeah, there are a few pain points. First being the playback. So we try to, when we send it to the consumer, we compress this content into as much of a compression as we can do, like without losing too much of the quality. But in the end, we have to always trade off with the quality. So when it reaches to the consumer, it's not already at the best quality that it can achieve. So there it's a limiting factor for the quality when it comes to the consumer. Since consumers today don't have too many devices that are able to play this back, I think it'll take some more time for consumer devices to get that capability to play back our content at its fullest level, fullest resolution, I would say. So that's one thing. Second would be again, how do you get this content to the consumer? So the distribution channels, they will have to get better. Like you said, 5G I think will be a key player there. Like 5G networks would enable getting this content more frequently, more quickly, and even in remote places where you don't have good Wi-Fi or anything. So 5G will definitely be helpful there. And uh, the third point is who's getting there. So I think it's already there in the sports arenas. If you see, Intel Sports has this 3D replay thing that you watch a game, like a soccer game. Some of the EPL games also have this capability, where you watch this game and the replay that you're watching of the key moments, you can view it in 3D from multiple camera angles. So it starts from there, and now it's coming slowly into Hollywood. And yeah, all these things, and now with the environment as it is in the world, these things are picking up. There's more demand for it. People are getting to know it, getting to feel it, and I think they're liking it.
When do you think it's going to get portable? Because I think that will be the key to it, right?
Uh-huh. Well, like I said, we have this app coming out very soon on the Play Store. Unfortunately, it's only going to be there in the US. But let's start. I mean, that's a good start, and see how how soon, how the demand is. If people really like it, I think we'll be able to put out more content, and it's something that remains to be seen. But yeah, I mean, already have the content out there. It's just that consumer devices need to be there, like to bring their A game to play it back.
Right. Bollywood is a big industry, right? I mean,
Mm-hmm.
are you
Sure.
guys exploring partnership? And B, uh, that we have these, cricket is a religion over here. I mean, obviously that's a big place to like kind of
Mm-hmm.
capture
Mm-hmm.
everything. Where does it start from? Would you be able to capture an entire basketball game? Would you be,
Mm-hmm.
what's the scale of it? Would you be able to capture a football stadium?
Uh-huh. So we are already doing it at football stadiums,
Wow.
the 3D replay. The basketball is also in progress. And I can say it's pretty good at that. Tennis, that's also a sport that we have looked at, that Intel has looked at. Um, Cricket, not just yet, but I think there is a big potential. Yes, it is very much possible. We have done it for football, so why not cricket? It has a billion viewers across the globe, so why not? So yeah, so there's actually no limit. Like you have all these big sporting events, and then you have all these fancy, colorful Bollywood movies. We're totally open to doing anything, any kind of collaboration there.
Lovely, lovely. So yes, I think I'm super excited about this. That definitely this is the future, and people don't even know. I mean, it's only the ones who are vested in the space who know about the AR, VR, MR, immersive tech space, and these really big companies who are experimenting with this. The larger population are completely unaware of
Yep.
volumetric capture and what it could be. Maybe we
Yeah.
could talk about it, but they, unless until they don't see
Yes.
it, feel it, I don't think they'll understand. So I feel that there's a need for a larger awareness where there should be, events where people talk about
Mm-hmm.
volumetric capture and make
Yeah.
people aware and make them experience it.
Oh yeah.
And I think it should start from the colleges and institute,
Oh
because
yeah. That's a
they,
great
they,
idea.
they are the future. If you start over there, it's like it'll be like a wildfire. It'll spread
Uh,
rapidly. So tell
And I
me.
think your immersive festival that you started there, that plays a key role there, right? I mean, that's the whole idea behind it, I guess.
Yes, so at the Immersion VR Festival, we had like a 30. I had built like a open like a viewing experience, like two different zone. Like one was like a 30-seater space where people were
Mm-hmm.
experiencing VR content, which was for your entertainment content. It was for your gaming and your entertainment content. Then there was like another breakout space where the content was very, your social impactful content. And through the 2-day event, it was completely jam packed. People were experiencing it and they walked out, oh wow, this is
Yeah.
this is VR. So unless and until I think people don't touch and feel it, it's
Oh yeah, totally.
impossible for them to fathom it. And I think haptic feedback will play a big role. I just
Mm-hmm.
imagine a future where I'm thinking just Bollywood, maybe like a Bollywood movie. Shah Rukh Khan is there, and you are in the movie,
Oh
and
yeah.
haptic feedback and volumetric, you are actually being able to be part of that narrative, that
Yep.
storytelling.
Yep.
It looks
You
super
can
exciting.
be in a scene. It'll be like Dancing with the Stars. You want to see yourself dancing next to Shah Rukh Khan. You could do it today with 3D volumetric capture, and it's very much possible.
Right.
And yeah,
Yeah, so
there's no limit to this technology. Like,
completely. So I'm super excited about it. So let me just talk about these. I mean, obviously you have these full-fledged volumetric studio, light capture, and things like that. Now there are these basic volumetric capture. I mean, there are these 3D depth sensing cameras. There's
uh-huh.
Azure Connect. Intel has a depth sensing camera. There's so many other. So there are these developers, content studios who are working with depth sensing cameras and building some decent volumetric capture. What now? What is the difference between? Can you just shine some light over there?
Yeah, so it's great to see, first of all, that all this consumer technology is picking up really well. And any hobbyist or any creator today, they can start making at least a partially 3D film. It will be like adding a new feature to your social TikTok video or whatever. Um, it's great to see that going into the creator's hands. At the same time, I feel that the quality of content is just not there. Like the resolution, first of all, with all these cameras that you were talking about, somebody who's doing this in their garage, um, you need to start with the basics. You need to have the right lighting. You need to have the correct cameras. You need to have high enough resolution. And then after that, you have all these computing capabilities that I was talking about. You need to have those. You need to have the right softwares. And that's what brings out all this nice content that we are building out. It needs a lot of care and human attention. Like even we have some artists who need to go in and make the scene look really good. So all that will definitely come from a studio facility like ours, but they'll be a little hard to achieve for somebody who's like a hobbyist. But yeah, I'm always open to see this, and I'm always very happy to see this happening.
Right. So importing your volumetric content into a gaming engine. Can you talk us through that process? And do you have partnership? Because some top gaming engine like Unreal have been right now, redefining the virtual production with Mandalorian, Lion King, stuff like that. So can you just talk about that?
Sure. So game engines like Unity and Unreal, as you know, they deal with 3D content, and 3D video is naturally like built around that content. Like you can just put it in there. You can take the 3D video that you captured at our stage and put it in any kind of scene or in a game or any kind of experience. And that totally changes the definition of the video. Like it was captured with something in mind, but now it has become something even more, which is more than the sum of its parts. So game engines totally open new avenues for interaction with this content. So you can have, let's say, you have like you said, a Kinect camera is looking at you and is looking at you as a user are doing different things, and it's recognizing your gestures. And then these gestures unlock something in the 3D video, which you are getting to see in real time. So those are the kind of experiences that I'm talking about. And that's something that you need to experience for yourself. And then you
exactly. Yeah.
And so totally. So we built demos with quite a few of these game engines. And the best part is that they support 3D video playback. And it's really cool, the final product.
Lovely. Super. Mohit, it was a pleasure chatting with you and understanding about volumetric capture or your volumetric studio. So what comes next for you? What comes next for Intel Studios?
Well, the moonshot, I guess, would be real-time volumetric capture and playback. So as soon as the scene is done shooting on our stage, we need to be able to review it and view the footage in full 3D. That's something which is going to take some more time. We are not there yet, but that will be really cool. So to be able to give a director the feedback that he wants, to be able to see how the scene looks like, that would be a totally new dimension to this technology.
Lovely. Thank you, Mohit. I mean, really appreciate you giving time and enlightening us about and sharing your insights about volumetric. I think we are at the cusp of some really cool things, and these technologies, I think, is going to define us, define mankind. The way we've been consuming content, the way we've been experiencing content, it's all going to change. And this change is obviously not going to be easy yet. There are these challenges, but there are people like you and others around the world who are trying to solve this problem, and it's going to be an exciting world. My kid who's behind me right now, and he's glued onto the TV. I mean, I'm so excited for him. I do keep on explaining to him that in another 10 years, possibly, you will not be sitting in experience. You'll not be a passive viewer where you'll be just sitting and experiencing content. You'll be part of the content. It'll be interactive. You will be able to interact with the content. So we're living in an exciting world, and I guess everybody needs to come together, play a role, be brave, and say that, okay, I've been comfortable with my whatever I've been consuming for the longest time with the medium or the interface, but I somehow like a father, I need to let that go and get into the new world. Get into the new world. We should not restrict ourselves, but I think the larger population is so attached to the old, they don't want to move on to the new one. So I personally am super excited about the new world. I'm personally excited about everything that's coming in new, but I do know that technology is a double-edged sword. So I'm taking these cautious steps, and I'm building a community. So I want to handle with people like you, so that we take everybody on together and we make sure it's a great and safe world for everybody. So on that note, Mohit, really appreciate you being part of XRM podcast. Wish you the very best to you and the entire team at Intel Studios. And to my listeners, if you like what you see and hear, please press the subscribe button. Like always, I'm going to leave behind all the details of Mr. Mohit Deopujari down below, so you guys can reach out and maybe you can collaborate and maybe you can come up with something better, right? So Mohit, really appreciate you being part of XR.
That's a great thought, and thank you for inviting me.
Thank you.
Nice talking to you.
Thank you.